golden brown, texture like sun, lays me down. With my mind she runs throughout the night.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
Here we have an irregularly shaped object that we know where the center of the gravity lies. We would like to move the location to the left by delta x, and let's say delta x should be 2.2 centimeters, for example. And to do that, we have additional mass, lump of something that weighs 1.5 kilograms. And the mass of this object, that's m1, is 5 kilograms. Another question is, where should we place this additional mass? First, it sounds like we cannot answer this question because there's no symmetry to this object at all. But by the fact that the center of gravity can be analyzed dividing it to its components, we can in fact do that. And we can also be clever about this by assigning our origin to the original center of gravity, like this. So x is there and y is in this direction. We solve this by remembering the definition of center of gravity or its location, so in the x direction. So x cg nu, it's the weighted average of these two masses, so m1 times the center of gravity of the object 1, and then the mass of the object 2 and its location or its center of gravity, divided by the total sum m1 plus m2. And where should this be? Well, it should be delta x to the left from the origin, which is the original one, so just minus delta x. And because our origin is where the original center of gravity was, then the location of the original mass is 0. And hence we can go on and solve from here. So m2 x2 is minus delta x times m1 plus m2, and then dividing by m2, so minus delta x m1 plus m2 divided by m2. So we want it to be 2.2 centimeters to the left, so minus 2.2 centimeters times m1, that's 5 kg, plus m2 1.5 kg, divided by m2 1.5, and that gives us minus 9.5 centimeters to the left. What about the y direction? So same thing. In y direction, the new center of gravity is the weighted mass of the two in the y direction, so m1 y1 plus m2 y2 divided by total mass m1 plus m2. And where do we want this to be? We only wanted to shift the center of gravity to the left, so there's no change in y direction. So relative to the original position, the CG in y direction is also 0. So, and we know that y1 was 0 to begin with because it lied in the origin. Hence, we can claim that in order for this to be 0, the y2 must also be 0. So we only go in the x direction by 9.5 centimeters and to the left.